Hello friends! In my previous video, we have discussed the advantages and disadvantages of friction. Hope you all remember those concepts. In today's video, we are going to derive few expressions related to the motion of a body on a rough horizontal surface. And we are also going to solve few example problems which will help you in your exams. So stay tuned till the end for some tips and tricks. So let's not waste the time and start the video. I welcome you all to Stardom Diploma. First, let us consider a body of mass m moving with an initial velocity u on a rough horizontal surface. So first we are taking a rough horizontal surface on which a body of mass m is moving. This body is moving with an initial velocity u, and since the body is in motion, we know that a frictional force, an opposing force, will act on the body, right? So due to this friction, the body slows down and its final velocity v becomes 0. After t seconds, the body comes to rest, and the distance the body travelled is s meters. So when the body is in rest, or when the body was stationary initially, it applied some force downwards. Yes, that force will be equal to mass into acceleration into gravity, right? And at the same time, another force exerted by a surface in perpendicular direction will also act. Yes, we read it earlier that a normal force acts by the surface onto the body in perpendicular direction. Yes, it is denoted by R or N. So this R will be equal to mass into acceleration into gravity. The body which was initially static, when it started its motion, when it began to move, we say it as limiting friction, right? We know the equation of limiting friction. Fs is equal to mu s into n or r. So Fs is equal to mu s into r. Yes, r is the normal reaction. We know what is normal reaction. Normal reaction is equal to m into g. So if you substitute, the limiting friction Fs will be equal to mu s into m into g. First, we are finding the retardation. Retardation and acceleration are equal, but they act in opposite direction. So if we find the value of retardation, we'll get the value of acceleration, and vice versa. If we'll find acceleration, we can find the value of retardation. Since they are acting in opposite direction, we'll keep a negative symbol. Now what is retardation? Retardation means it decreases the velocity per unit time. Whereas acceleration, it increases the velocity per unit time. Yes, that is why acceleration and retardation, their value is same, but they act in opposite direction. Here, to find acceleration, we are using retardation. We can directly find acceleration, but why we are using retardation formula? This is because retardation is decrease in velocity. So velocity will be decreased when its motion is opposed. See, motion is opposed by friction. Here there is a friction. See, if we were having an applied force, then directly we can use the formula force by mass is equal to acceleration. We will directly get the value of acceleration. But here we are not having any applied force, but we are having a frictional force, an opposing force which is decreasing the velocity of the body. So now let us find the retardation. Retardation will be equal to retardation force divided by mass. Here retardation force is the limiting friction. So Fs divided by mass. We found the value of Fs. Fs is mu s mg. So retardation will be equal to mu s mg by m. Here m, that is mass, will be cancelled in both the numerator and denominator. Finally we will get the retardation, that is mu s g. We said that retardation and acceleration values are same, but they are acting in opposite direction, so we'll keep negative symbol. So the acceleration A will be equal to minus mu s into g. Now let us take this as equation number 1. We are having initial velocity is u and final velocity v equals to 0. The time of travel, the body, how much time did it travel, is t seconds, and acceleration we found it as minus mu s into g, and the distance covered is s meters. So now we are applying third equation of motion, that is v square minus u square is equal to 2as. Yes, in this equation we are going to substitute the values. All values are the known values, only the distance traveled, that is s, is unknown value. So from this equation we can find the displacement of the body which is moving on a rough horizontal surface. If we substitute the values, we will get 0 minus u square is equal to 2 into minus mu sg into s. So finally s will be equal to u square divided by 2 mu s into g. This is the expression for displacement of a body moving on a rough horizontal surface. Next, if we substitute the same values in first equation of motion, v is equal to u plus at, we can find the value of t, that is time taken to the body to come to rest. So 0 will be equal to u minus mu s into g into t. So t will be equal to u by mu s into g. This is the expression for time taken by the body to come to rest. Now we'll find an expression for work done on a body by the frictional force. Yes, the body was in motion and an opposing force, an opposing frictional force was acting on the body. So what is the work done by this frictional force? We are going to find an expression for this. We know work done will be equal to force into distance. Here the frictional force which is acting is the limiting friction. We found that limiting friction is equal to mu s into m into g, and the distance is nothing but the displacement, that is a distance travelled by the body till it came to rest position, that is s. So work done will be equal to frictional force into distance, and which is equal to mu s mg into s. This is the expression for work done on a body by the frictional force. Now let us solve few problems based on these expressions. See, not only solving it, but we have to follow certain steps. Okay, about that also we'll see now. So first question, a force of 98 Newton is required to pull a body of mass 200 kg over ice. What is the coefficient of friction? So in step 1, what we have to do is, we have to read the complete question carefully and note down what are given in the question. See, we said a force of 98 Newton is required to pull a body. So there is a body, and to pull the body we require 98 newtons of force. So force F will be equal to 98 Newton and body of mass 200 kg. So the mass of the body M is equal to 200 kg and this body is placed over ice. So in step 1 we have to write what are given in the question, and in step 2 we have to write what we are going to find. In this question, what did he ask? He asked what is the coefficient of friction? Mu. Mu is the coefficient of friction, right? So mu is equal to question. In this question, we need to find the value of mu using what are given in the question, that is the force and mass. 2 steps are completed. See, observing these values, I think you got a formula. Force is equal to coefficient of friction into normal reaction, right? F is equal to mu n, where F is the applied force, mu is the coefficient of friction, n or r both represent normal reaction. We can either keep n or either r. So from this formula we can find the value of coefficient of friction. So mu will be equal to F by n. Here we are having the value of force F, right? So R, that is a normal reaction. We already know normal reaction N equals to M into G, that is mass into acceleration due to gravity. So mu will be equal to F by M into G. Now we'll substitute the values in it. Mu is equal to F. Force is 98, mass is 200 kg and acceleration due to gravity, that is G, will be equal to 9.8. Solving this, we'll get 1 divided by 20, which is equal to 0.05. So this is our result. He gave us to find the coefficient of friction and we got the value of coefficient of friction, which is 0.05. So using these steps, step 1 we have to write what are given in the question. In step 2 we have to write what we are going to find, what we have to find. And in step 3 what are the formulas related. And in step 4 we have to solve. While solving a problem, these 4 steps we have to definitely follow. Okay. Now moving to second question. A body of mass 10 kg is moving on a rough horizontal surface. Find the force required by the body. And the coefficient of friction is equal to 0.5 and acceleration due to gravity is 9.8 meter per second square. For this question also we are going to follow the same 4 steps. So the body of mass 10 kg, m is equal to 10 kg. It is moving on a horizontal surface and we need to find the force required. So here we are having the value of mass, coefficient of friction and acceleration due to gravity. So what are given in the question after writing it? In step 2 we are writing what we have to find. Here in question he gave us to find the force required by the body. F is equal to question mark. In this problem also we can use the previous formula. F is equal to mu n. We have to write the formula. F is equal to mu n. N is normal reaction. N will be equal to mass into acceleration due to gravity, right? N is equal to m into g. So in the place of n we are substituting m into g. So F will be equal to mu m into g. So here we can substitute the given values. The force will be equal to 0.5 into 10 into 9.8. By solving this, we are getting the value of force. The force we need to apply is 49 newtons. See, not only finding the answer, we have to also write the units. See, if he asked us force, we have to write newtons. Distance the body traveled, that is the displacement. Then we have to write the meters. We have to not forget the units. Units are also important. Moving to third question. A body of mass 100 kg rests on a horizontal surface with coefficient of friction 0.2 in between. Calculate the work done in dragging the body through a distance of 100 meters. What are given in the question is body of mass 100 kg. So the mass of the body m is equal to 100 kg. This body is resting on a horizontal surface and the coefficient of friction between the body and the surface is 0.2 and the body is being dragged through a distance of 100 meters. So these are given in the question and we have to calculate the work done. So in step 2 we are writing W is equal to question mark, that is we need to find the work done in dragging the body. You know the formula of work, right? Work done will be equal to the force into displacement. Okay, force we already know, force is mu n. N is normal reaction, n is mass into acceleration due to gravity. So force will be equal to mu m into g. Work done, force into displacement. So F is mu mg. Work done will be mu mg into s. We are having all the values. We are having the value of mu, mg and also s. We are going to substitute it. Work done will be equal to 0.2 into 100 into 9.8 into 100. After solving, we are going to get the work done in dragging the body. So finally the work done will be equal to 19,600 joules. Moving forward, now we'll look into the fourth question. It is little different, but we'll understand it. Okay, a body of mass 5 kg is moving on a horizontal plane with a speed of 36 km per hour. The coefficient of friction between the body and the plane is 0.2. Find the minimum distance travelled by the body before it is brought to rest. Acceleration due to gravity is given as 10 meter per second square. First, we'll note down what is given in the question. So, body of mass 5 kg. So, mass of the body m is equal to 5 kg. It is moving on a horizontal plane with speed of 36 km per hour. So, in the question, he gave that it is moving with a speed. Speed is nothing but we can take it as velocity. At the beginning only, the velocity of the body is 36 km per hour. So, the initial velocity u is 36 km per hour. If we take it as meter per second, we need to multiply it with 5 divided by 18. So, initial velocity u will be equal to 10 meter per second. And the coefficient of friction between the body and the horizontal plane is 0.2. So, mu is equal to 0.2. Here they already gave acceleration due to gravity as 10 meter per second square. So, g is equal to 10 meter per second square. And we need to observe the last line. He said us to find the distance travelled by the body before it is brought to rest. He gave that the body is brought to rest. See, at the beginning of the question, he said that the body is already in motion, and he said the distance up to which the body will come to rest. There is some final point. So the final velocity is 0. Okay, you are understanding it? See, the body is brought to rest. Its velocity is decreasing and finally it reached 0. When it reached 0 means the body is brought to rest, right? So initial velocity is 10 meter per second and the final velocity is 0. Now we have to find the minimum distance travelled by the body. The body, how much distance it travelled from the starting point to the ending point, we have to find it. We need to find displacement S. So S is equal to question mark. This is our step 2. We have noted step 1, what is given in the question, and step 2, what we have to find. We need to find the displacement. Now here we can use the formula. That is a third equation of motion. I hope you remember it. V square minus U square is equal to 2as. Using this formula, we can find the displacement S. So S will be equal to V square minus U square by 2a. See, in this formula, all are the known values, but a, that is our acceleration, is the unknown value. So to find the value of displacement, to find S, we need to first find out the value of acceleration, and then if we substitute the values, we are going to get the distance travelled by the body. See, we are using the formula of force. Force is equal to mu r, or force is equal to mu n. N is the normal reaction. N is equal to mass into acceleration due to gravity, and force is also equal to mass into acceleration. So m into a is equal to mu into m into g. We are having left hand side values and right hand side values. Mass will be get cancelled on both sides. So acceleration will be equal to mu g, where mu is the coefficient of friction and g is the acceleration due to gravity. We know both the values, right? So a will be equal to 0.2 into 10. So the value of a, acceleration, will be equal to 2 meter per second square. Here our acceleration will be negative. Why? Because first the initial velocity was 10 meter per second, and when the body reached rest, the final velocity v becomes 0. That means there is a decrease in velocity. Decrease in velocity is nothing but retardation, right? Retardation, or it is a negative acceleration. We can tell it as negative acceleration. Increase in velocity is acceleration, positive acceleration, and decrease in velocity, since the velocity is being decreased, the value of acceleration will be negative. So here the value of acceleration a will be minus 2. Now we are going to substitute minus 2 in the formula of displacement. We have got the formula of displacement as S is equal to V square minus U square divided by 2 into A. So the value of V, final velocity is 0, initial velocity U is 10, and acceleration is minus 2. So S is equal to 0 square minus 10 square divided by 2 into minus 2, which will be equal to minus 100 divided by minus 4. Minus and minus will be getting cancelled, and if we solve it, we'll finally get the value of displacement, that is 25 meters. So the distance travelled by the body before reaching rest is 25 meters.
Friends, I hope you are clear with these problems. Just remember one thing, and this will be cakewalk for you. First, write what is given in the question. Then, what we have to find. After that, what are the formulas related? And finally, solve it. Remember that everything is in the question itself. Just you have to find it. In this way, solve all the remaining problems also. In my next video, I will provide you with some important questions and notes of chapter 1.
And this was today's video. Hope you all start the topic. If you still have any doubts or have any suggestions, feel free to post it in the comment section below. Please support my channel. And don't forget to like, share and subscribe. Even press the bell icon to get new updates. Okay friends, see you all in the next video.